This is a basketball machine, and this is a desktop version of it. I wanted to play with a basketball machine, but I lacked the space and the money. So instead, I made a smaller, more affordable version. My goals were clear from the beginning. I wanted to use an Arduino Nano for space efficiency, 3 2-digit 7-segment displays to show time, score, and highest score. I wanted it to have 2 game modes, one where you can play for 60 seconds and another where you can play for 90 seconds. In order to achieve this, I needed 3 different buttons, one to start or pause the game, one to reset the timer, and one to change the game mode. With the project's current state, you can choose 60 or 90 seconds, press start, and the timer will start to go down. You shoot the ball from the launcher, and when it enters the basket, point is added to the score. When the timer reaches 0, the highest score of all the games in that game mode will be shown in the high score display, and the game over LED lights up. Then you can hit reset and start again. The points are counted using a cleverly placed infrared sensor below the basket. Whenever a ball goes through the basket, it has to go through the sensor. By far, the hardest parts of this project were the 3D design and the method to make the displays work. In the design part, it was hard because I had to first learn CAD. I watched a lot of YouTube tutorials and eventually got the hang of Fusion 360. The basketball machine was the first design that I made completely by myself, and even though it can use some big improvements, I'm still very proud of it. Now, the 7-segment displays were a little tricky. In essence, they are just 7 LEDs cleverly placed in order to make numbers. For example, to make the number 1, you have to light up the 2 LEDs far to the right. To make the number 2, you have to light up 5 LEDs, and so on and so forth. The displays I'm using literally have a pin for each LED, so in the Arduino code, I have to assign each number to a combination of zeros and ones, meaning that the LEDs are on or off. In total, my 3 displays have 54 pins, which is way more than the number of Arduino pins, so I had to find a workaround. I did some research and ended up trying to do multiplexing with transistors. Multiplexing is a technique used to control multiple 7-segment displays using fewer microcontroller pins. Instead of powering all displays at the same time, we turn them on one at a time very quickly. Because this switching happens faster than the human eye can notice, all displays appear to be on simultaneously. Each display shares the same pins. These pins control which LEDs light up. What changes is which display is enabled. This is where transistors come in. A transistor acts like an electronic switch. Each display has its own transistor connected to its enable pin. The microcontroller activates one transistor at a time, selecting which display is currently on. However, I was unsuccessful using this method, so instead I went for shift registers. An 8-bit shift register is an easy way to control a 7-segment display using very few microcontroller pins. Instead of connecting each LED directly, the microcontroller sends data 1 bit at a time to the shift register using a data pin and a clock pin. Each bit controls one LED. The 8th bit can be used for the decimal point. Once all 8 bits are sent, a latch signal updates the outputs and the correct LEDs light up to show the digit. To control more displays, multiple shift registers can be connected in series. The data pin of one register feeds into the next, forming a chain. With that, I landed on using 6 shift registers, one for each digit. after the entire system was working on the breadboards, I wanted to make the project more solid. In order to do that, I designed a PCB and had it manufactured using JLC PCB. With the electronics done, I started designing the body of the machine. And after many iterations and many mistakes, or as I like to call them, learning experiences, I landed on this final design. I printed everything out of black and white PLA using an A1 Mini. I assembled all the parts with super glue and the PCB fit right in. With the project finished, you can plug it into your laptop with a USB cable and enjoy the game. I realized that there is a lot of improvement to be done in every aspect of the project. The PCB isn't ideal and the components heat up sometimes. The machine could be assembled using screws instead of glue, and the sensor sometimes doesn't count the points, which could be fixed using 2 sensors for a bigger wrench. In spite of all of these inconveniences, I still like the end result of this project, and I learned a lot while making it. Maybe in the future I can make a new and improved basketball machine. Still got some issues, but... Oh, nice. Oh my god.